Take a close look inside, it's not a bad finish. And I'll try in the magneto. I'm not too happy with the final result there. It seemed alright on the last one, but I'll run it through again. Well, I took a couple of passes and I gripped the tip of the end of the boring bar between my finger and thumb, stopped the chatter and allowed it to cut, and I've just tried this in and it's a good fit. If anything, it's slightly tight at the top end here, which is what I prefer because it'll get more grip that way when it's tightened onto the shaft, so I'm happy with that. So that's me with a program now for cutting magneto shaft tapers, particularly for Lucas, and I think this will also do for one or two of the other ones. I think they have a standard size shaft. I think this is the medium sized one. Anyway, the next process will be to generate the G-code to cut the sprocket teeth. I'll probably go to finish off the rest of the thickening, or taking this down. Before I do that, just using the facing program, just anything to try out the lathe and the path pilot, and we'll see what happens. I'll keep you posted. Done a little bit of work with the little scraper in the lathe here, not too much, about 5 minutes work, and you can see now it's pretty good. There's good, when you ring it together, there's good bright spots for all the full length of the taper, so I'm happy that that's sitting correctly. So the next phase will be the sprocket. Take a close look inside, it's not a bad finish. And I'll try in the magneto. I'm not too happy with the final result there. It seemed alright on the last one, but I'll run it through again. Well, I took a couple of passes and I gripped the tip of the end of the boring bar between my finger and thumb, stopped the chatter and allowed it to cut, and I've just tried this in and it's a good fit. If anything, it's slightly tight at the top end here, which is what I prefer because it'll get more grip that way when it's tightened onto the shaft, so I'm happy with that. So that's me with a program now for cutting magneto shaft tapers, particularly for Lucas, and I think this will also do for one or two of the other ones. I think they have a standard size shaft. I think this is the medium sized one. Anyway, the next process will be to generate the G-code to cut the sprocket teeth. I'll probably go to finish off the rest of the thickening, or taking this down. Before I do that, just using the facing program, just anything to try out the lathe and the path pilot, and we'll see what happens. I'll keep you posted. Done a little bit of work with the little scraper in the lathe here, not too much, about 5 minutes work, and you can see now it's pretty good. There's good, when you ring it together, there's good bright spots for all the full length of the taper, so I'm happy that that's sitting correctly. So the next phase will be the sprocket. Here I am, still playing with the duality lathe. I've just hijacked one of the conversational programs and converted it to doing back facing. Got the lathe running here, but you can see it's set up to cut this back face. Here you can see the tool pass, and it's looking quite good. I'm on single block at the moment, but I'm pretty sure everything looks fairly good, so I think we'll hit the go button and see what happens. And here we go. And it should do a pass or two without quite a few passes actually, looking at it, but never mind, I can adjust it a bit later. It's just a try out, and there we go, bottom of the cut, lovely. Well, I'm well pleased with that programming. It seems to have worked great. That's virtually from scratch. I've just hijacked the start of one of the conversational programs. It gives me my feeds, etc., and the conditions. Saves you a lot of fuss. Just take that and then start from your first pass and work it out. It doesn't take much, it's only in 2 planes. And off you go. And here we can see it's okay, it's got a long way to go before it starts cutting. And that's probably just down to slight setup differences. But it's nearly there, it's nearly cutting. Yeah, I just realised that the quickest solution to this problem was to, because I'm back facing and the work was a little further away from the tool when it started than I wanted, and it's not critical where the face ends up. The easiest way to solve that was just to move the work in the chuck towards the tool. So that's what I've done. So we'll switch on, and this time we should see it working. And here we go. I'm not going on single block. And it's just touching, and now I can see it's starting to cut straight away, which is lovely. There we go, lovely. You notice also very fine cuts, tooth out at a time, lots of passes. The only way to do it, there's not much power in this, and I haven't got any stop set up yet, so the last thing I want to do is get too ambitious. But it leaves a nice finish, so I'm quite happy with it. Okay, we'll see what it looks like when that fits. Okay, well, I've finished back facing this. You can see the finish again is really nice on here, but on the diameter it's very poor. There was a lot of chatter as the tool got down to the face. You can see it was just a sharp sharp burst of chatter as the tool bottomed on its cut, and it's very hard to focus on it, but you can see there there's a row of chatter marks, but it's irrelevant anyway. It's not seen, but it's not very nice. I would sort that out by different tool geometry, I think, in the future. Need to look at that. I don't know why it was causing that. Maybe it was too far below centre, the tool, which would cause it to chatter. But anyway, you'll notice a couple of rather nasty marks from the jaws of the chuck. And that was because one of my Z's, the Z references to move the tool, and the Z axis, I forgot to put a 0 in, minus sign rather, and I wondered why on line 25 twice it stalled out on me, and of course it tried to rip the work out of the chuck, but because the lathe was moving away from the tool in the positive Z direction, and of course fortunately the tool post is just a single bolt, so the tool just swung around and left a gouge in the part, but I still had a long way to go, so I recovered from that. I got into the G-code. I did it twice actually. The second time I thought, well, that looked to me as there's something wrong with the program, so I went in the G-code, and sure enough on line 25 or line 26 I had forgot to put a negative sign on the Z direction. It was on, actually the part it was at the bottom of the cut. I had the tool moving away from the work by 1/1000th of an inch, and then going back to the start position before it started its next cut, and it was that dimension there, so it was right. There couldn't have been a worse place to have a negative dimension. If it had been at the outside diameter, it wouldn't have mattered too much, it wouldn't have done any harm. But anyway, and another annoying aspect of course is the lathe. Well, I suppose it's not too annoying. Well, it is annoying because the lathe continued to turn, or tried to turn, but it stalled out anyway. I should have the stop cable fitted, but it's on its way from the USA. It should arrive within the next week or so. But overall I'm quite pleased with things, because it's path pilot, well, not necessarily path pilot, but certainly I'm finding the lathe, actually programming the lathe using my own G-code is easier than the mill so far, but of course it's good practice, and maybe I'll get round to doing the same with the mill for simple stuff, but this is quite easy. Okay, well, next phase will be to counterbore that and then take the mini lathe off, the duality lathe off the milling machine, parking that on the bench, and I'll put the sprocket or the blank on the table, and we'll cut the teeth using the milling 3-axis. We've got the machine set up to do the finished boring of the inside of this sprocket for a magneto. No real trouble setting it up. It seems to be going okay. Oh, we're getting a nice cuttings coming out the end of the spindle. Initially I had a lot of chatter, but I slowed down at the end and that looks to be perfect. That sounds lovely. No sound of cutting, which is what you want. Lovely. So we'll see how that progresses. It's got to have another bore. This is a kind of counterbore hole if you like, so I'll reset the machine to do the larger hole, and that'll be all the turning finished. The next process will be to put everything into the mill, just take the lathe off the bed and do the sprocket teeth. Well, the machine seems to be quite happy with the feed and the speed, and it's doing nicely. You can see there, not much to go on this one, about a tenth of an inch or so, and that will take that up to its final size for the length of the bore, and then I've got to count. That's a counterbore to start. Well, there you can see it's a nice cut, doesn't look too bad at all. Occasionally give it a little bit of WD-40 as a lubricant. I'm quite happy with things. So we're nearly finished with the counterbore. As you can see from the slider on the program, there's not much more to go. You can't really see it that well on this, but there you go. And you can see on the live screen there's only a few runs to go before it's finished. And you can see the finished article, counterbore, the bore right through, taper at this end to suit the magneto. Not very good finish on this part, but generally everywhere else exceptionally good. The OD is a little bit chattery, but the facing is beautiful. I'm well pleased with the finish. So next thing will be to remove the lathe from the mill, tidy up, get the vise in, and first things we'll probably do will be to put an internal thread on here, 5/8 by can't remember what pitch, but certainly 5/8 by 26 threads pitch, to take an extractor which you can just screw into the centre, push down onto the end of the magneto and drive the taper off. It's quite an essential tool, especially if you've got your timing wrong. But other than that, that'll be the first job rather, and then next job will be to make the sprocket teeth, but we'll see later.